Good day, everyone. Thank you, Far Eastern University Roosevelt, for this opportunity to be here today for my capstone project presentation. My name is Carlo Jade Lisondra, a Bachelor of Science in Industrial Engineering and a graduating student at Visayas State University Isabel Campus. And my capstone project is all about optimizing the operation of a gasoline station using queuing analysis. In this capstone project, we will investigate how queuing analysis can be used to optimize the operation of a gasoline station. Queuing analysis is a mathematical tool that can be used to study the behavior of waiting lines. By applying queuing analysis to a gasoline station, we can identify areas for improvement and develop strategies to reduce customer waiting times. Customers who experience long wait times at the gasoline stations are likely to be dissatisfied or may take their business elsewhere. Queuing analysis can help gasoline station managers to identify bottlenecks in their operation, such as the number of pumps available or the speed of service. By addressing these bottlenecks, gasoline stations can reduce customer wait times and improve customer satisfaction. In this study, the PASAR Employees Multi-Purpose Cooperative Management wants to determine the current situation and service capacity of their gasoline station and identify possible improvements for them to increase the service sales and customer satisfaction. The research objective was to study the queuing system at the PASAR Employees Multi-Purpose Cooperative Gasoline Station in Mahayag, Isabelete. Specifically, the study sought to conduct a queuing analysis to determine the following: service rate, arrival rate, behavioral characteristics of queuing system like the average number of customers waiting in line, the average number of customers in the system, the average waiting time for a customer, the average total time of a customer spends in the system, and the utilization rate of the system. Second, identify the various possible alternatives that optimize the operation of gasoline station and determine the optimal alternative for the operation of the gasoline station. The study was conducted at a gasoline station located along the National Road Highway of Mahayag, Isabelete from March 18 to May 16, 2024. This station is one of the branches established by the PASAR Employees Multi-Purpose Cooperative alongside the station in Look, Matlang, Isabelete. The Mahayag station began operating in 2014. The establishment has existing 5 pumping attendants, 3 pumping machines, and the operation time from 5 a.m. in the morning and 9 p.m. in the evening. The tools used in conducting the observation at the gasoline station are the arrival rate observational sheet, service rate observational sheet, and the stopwatch. And the tools used in treating the gathered data from the observation were the queuing model and the Monte Carlo simulation. Following the instrument's validation, the researchers secured a letter of approval from the establishment's General Manager of PEMC gasoline station. Afterward, the researcher conducted a 14-day real observation. Prior to that, the proponents collected qualitative data about the peak hours or periods during the 14-day observation from the pump attendants. The arrival rate of consumers who reach the area every 5 minutes between 5 a.m. and 9 p.m., as well as the service rate of customers from the moment they approached to the pump attendant until they departed, were recorded by proponent during the real observation. The proponent gathered the arrival and service rate data and then performed a Monte Carlo simulation to evaluate and interpret the information. Afterward, the ideal alternatives were determined and the best alternative was provided. The arrival rate refers to how frequently items enter a system within a specific time frame. The arrival rate was calculated by dividing the number of customers per day by the number of hours and minutes in a day. For example, on day 1, there were 391 customers, and the arrival rate was 49 customers per hour. This suggested that customer arrivals were higher at the beginning of the 14-day period. The arrival rate in a gas station is the speed at which customers can fill up and finish their transactions. Each day had a number of customers served per day and a service rate per hour. For example, on day 1, there were 391 customers and a service rate of 50 customers per hour, which means that on average, the pump at the gas station could service 50 customers in an hour. The data clearly indicates that during the initial 14 days, there was minimal queuing owing to the lower arrival rate in the comparison of the service rate. On average, the system experienced an influx of 45 customers per hour while successfully serving 55 customers within the same time frame. The system's utilization rate stands at 104%, signifying a full capacity utilization. Overall, the utilization of 104%, the system needs to be improved to decrease the utilization rate to its ideal range to avoid exhaustion, stress, overwork of the machines and attendants. Maintaining good customer service in the queuing systems is linked to keep server utilization below 80%. This guideline, commonly used in queuing theory, may vary depending on specific factors. Currently, the station has 3 pumps with an average arrival rate of 45 customers per hour, while the service rate can accommodate at 55 customers per hour. This results in a utilization rate of 104%. A utilization rate of over 100% indicates that the system is overloaded. This means that with the existing number of pumps, more customers are arriving each hour that can be serviced, which likely leads to long waiting times for customers. In getting the optimal alternative, for 3 machines, the total arrival rate of 3 machines is 553 customers, and its average arrival rate is 40 customers per hour, while the total service rate for 3 machines is 687 customers, where the average service rate is 49 customers per hour. While in one pumping machine, the total arrival rate per machine is 104.33 customers, and its average arrival rate per machine is 13.17 or 14 customers per hour. The total service rate per machine is 229 customers, and the average service rate will be 16 customers per hour. For the total arrival rate of the 4 machines, it will be 737 customers, while the average arrival rate will be 52 customers per hour. While its service rate, the total service rate will be 916 customers, while its average service rate of the 4 machines will be 65 customers per hour. For the utilization rate, we have delta over mu, which is 52 divided by 65 is equal to 0.8 or 80%. For the average number of customers waiting in line, we have 52 times 52 over 65 times 65 minus 52, or 3.2 customers or 4 customers. For the average number of customers in the system, we have 52 over 65 minus 52 is equal to 4 customers. For the average time waiting in line, we have 52 over 65 times 65 minus 52 is equal to 0.062 minutes. And for the average total time in the system, we have 1 over 65 minus 52 is equal to 0.077 minutes. The recommended optimization suggested adding 1 more pump for a total of 4. This was counterintuitive as it increased the average service rate to 65 customers per hour and the arrival rate to 52 because there were more pumps to service the number of customers. However, with 4 pumps, the arrival rate and the service rate were better, bringing the utilization rate down to 80%. This rate of 80% was deemed optimal, ensuring customers did not experience excessive waiting times, and the station could serve more customers efficiently due to the attendants having more rest than existing ones. At the PEMC gasoline station, the price of the gasoline and diesel fuel were based on the actual pricing of the PEMC gasoline station. Furthermore, the average fuel purchases per customer and the operational hours are based on the estimation and validated with the PEMC management. The table showed that there were a possible average annual increase in sales amounting to 418,725 or 17.33% if the management will hire additional 1 pumping machine. Based on the PMC management, the pumping machine will cost 250,000 pesos. If the management will invest in 1 machine, it will take 7.16 months to recover their investment. In this study, the researcher recommended that the management should add another 1 pumping machine to reduce the utilization from 104 to 80%. Furthermore, the PEMC management may evaluate the current layout to allocate smaller vehicles such as motorcycles to another pumping machine to maximize space while serving larger vehicles at the main pump. Additionally, it was suggested to extend promotions and advertising efforts to non-PEMC members to enhance sales and attract larger customer base for vehicle refills. Thank you for listening. This research opens doors for further exploration in improving the study. I welcome your questions and feedbacks to help guide this research forward. Again, thank you and good day.